Knowing how to interpret freeze frame data can help you diagnose electrical and sensor faults much more efficiently. Let's see how to read freeze frame snapshots the right way and how to avoid the most common mistakes. When a fault code sets, the ECU stores a freeze frame, a snapshot of key operating data at that exact instant. This information can reveal important clues about system conditions right when the problem was detected, which helps you avoid blind part replacement. Freeze frame shows only what the ECU saw at its sensor and input pins, not necessarily what was really happening in the system. A wiring issue, shared ground, or offset voltage can fool the module and the freeze frame. Freeze frame typically records RPM, load, sensor signals, temperatures, and sometimes vehicle speed or throttle position. These reveal the operating conditions when the fault was set, such as whether the engine was hot or cold, loaded or idling. Reading these values tells you where to focus your tests. Interpreting freeze frame means knowing the difference between typical and out-of-range values. For example, was the sensor reading abnormally high or low for the engine speed and load? Compare the captured data to what would be expected in those circumstances. It's important to confirm whether the scan tool's freeze frame or live data reflects what's actually present at the pin or in the system. A voltage drop, wiring fault, or bad ground can cause the ECU to see something very different than what you measure directly. Always use a meter or scope to check the real signal and compare it to what scan data reports. Start with the freeze frame snapshot. What was the engine doing? Use that to recreate the fault condition if possible. Then verify power, ground, and signal right at the ECU and at the sensor. Only after checking these should you move to part testing or replacement. Never assume that a scan tool PID or freeze frame value is the final answer. Faulty wires, connections, and shared grounds can all fool the data. Guessing based on a data snapshot leads to unnecessary parts replacement and unresolved problems. Always confirm the root cause with tests and measurements. Use the freeze frame as a test selector, not a verdict. First, identify the operating condition when the DTC set, such as load, speed, temperature, or RPM. Then recreate or approximate that condition. Compare current live data to the stored freeze frame and choose the next targeted test from the mismatch. The point is to prove what changed under the same condition before replacing a part. Use the freeze frame as a test selector, not a verdict. First, identify the operating condition when the DTC set, such as load, speed, temperature, or RPM. Then, recreate or approximate that condition. Compare current live data to the stored freeze frame and choose the next targeted test from the mismatch. The point is to prove what changed under the same condition before replacing a part. Freeze frame data helps you understand what the system was doing and how the ECU interpreted it when the fault set. When you confirm scan data with real-world testing, you can target your diagnostics and avoid wasted time and parts. By understanding and confirming freeze frame data, you take control of the diagnostic process and work smarter, not just faster.